Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC Problem of the Week video, and this is a really advanced problem about trying to find the number of squares bound within a region on the coordinate plane. So without further ado, let's get on with the video. This is AMC 10B, problem 14 of the year 2016. How many squares whose sides are parallel to the axis and whose vertices have coordinates that are integers lie entirely within the region bounded by the line y equals pi x, y equals negative 0.1, and the line x equals 5.1? Your answer choices are 30, 41, 45, 50, and 57. The keywords here are squares, and sides are parallel to the axis. And the vertices have coordinates that are integers, and they lie within this region, which here are the three lines that bound the region together. Now, the best way to solve this problem is to have a visual representation. So, looking at these three lines, we can see the three lines are y equals pi x, y equals negative 0.1, and x equals 5.1. What you notice about these is that none of these are full integers, but they are really close to 1. So this would approximately be about 3x, this is approximately 0, and this is approximately 5. So when we are drawing the diagram, they are just doing this so that you can see that the integers, for example, x equals 5, is in this region. Now, drawing this diagram. So since this is about y equals 3x, then the slope would be about 3. And since x equals 5.1, it's about x equals 5. And we can see that this would be the line x equals, and this is the y equals pi x. And they meet at a point right here. And the bottom is about the x-axis. It's right below it, so all these points on the x-axis are on here. Now, when we are drawing the points in, we have to first see where these two lines meet. When x equals 5, what is this? It's about 15. So this point is about 515. So we can see here that the dots would be 1, 2, 3, 4, and 5. And then up here, there's 15. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this is within the region, so this dot also counts because I'm drawing the approximate lines. Now that we have this, we can draw the other dots that would be in this region. Since this is a slope of 3, we can see that it would be 3 up from every time it gets cut off. To find the total number of squares, we can first look at the squares that are 1 times 1 squares, and then 2 times 2, and then 3 times 3. So the squares that are 1 times 1. Remember, all of these lines on the side count because I'm drawing the approximate line. We can just look at this diagram and count these squares if you want. So first, we can start from right here. This square right here, this will be 1, go down 1, 2, 3. And then this is where this gets cut off, and then this starts 2 times 2 squares. So there will be 1, 2, 3, 4, 5, 6, and then we get to this side. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down here, which is 1, 2, 3, 4 times 1, 2, 3, which would be 12. Now add these all up, and then there's 31 times 1 squares. Remember, when they're looking at squares, it can also be 2 times 2 squares. So now this is what we're going to look at next. 2 times 2 squares. But we know that right here, there's no 2 times 2 squared because the largest length would be 1. So we had to skip to right here, which is 1, 2 times 1, 2. Remember, we're not counting the dots, but rather the line in between. So it's like 1 unit squared. So there will be 1 right here, and then we move down, and there's 2. When we get to this next row, where we get 1, 2, and then we have to add these, the one that we missed right here, which will be 3. Go down, we get 4 and 5. And then move down more, there is 1, 2, 3, 4, 5, 6. And then remember the ones we missed right here will be 7 and 8. So that would be 15 squares. And then similarly, we get the 3 times 3 squares. There are 5, which is 1, 2, 3 right here. 1, 2, 3, 4, 5. And that's it. So adding all these up, it would be 30 plus 15 plus 5, which is 50, and that would be our answer. So looking at our answer choices, we can see that the answer will be D, 50.